All right, just taking a few minutes to update this lesson. Where's my mouse? So for warm-up, let's determine the integral of x plus 3 over x dx. And in a case like this is pretty easy because we can split out x plus 3 over x into x over x plus 3 over x dx, which is the integral of 1 plus 3 over x dx. And now we could split it out and write it as the integral of 1. Well, I mean, we'll just pop up here and do that. So it's the integral of 1 dx plus the integral of 3 over x dx, and that is going to be equal to, so this integral, and you can just do it straight from here, so just going straight from here, the integral of 1 is x plus, and the integral of 3 over x is 3, absolute value ln x. And then, of course, we need plus c. But, so, well, as you can see, if the integral of f of x dx, where f of x is a rational function, there's a monomial denominator. The integral is easy to determine. So that is the goal for each of the following, since the substitution method used in part A would not work here. So if we want to get a monomial denominator, where did my mouse go? We want to get a there we are. If we want to get a monomial denominator here, x minus 4, let's start with let u equal x minus 4. Now, if we solve that for x, that means that x is equal to, so we're going to add that, u plus 4. But what we need is, we need du, and du is going to be 1 dx. Right? So, now if we look over here, what have we got? The x will be replaced by u plus 4. The x minus 4 will be replaced with u, and we will now have, this is equal to the integral of u plus 4 over u, and the dx, well, that's just du. du. And now this looks an awful lot like that, so we're just going to go straight to the answer. Well, okay, let's do one thing. So u over u is 1 plus 4 over u du. And now we go straight to the answer. So we've got u plus 4 ln absolute value of u plus c. But it's not all about u. It's about x. So, let me drag this down a bit. Okay, so u is x minus 4. So u plus 4 times the ln of the absolute value, and u, well, u is still x minus 4. X minus 4 plus c. And then we have a constant here, minus 4, and a constant here. So we can roll this minus 4 into this constant here, and we will just say we've got x plus 4 ln absolute value of x minus 4 plus c, well, or if you like, you can call it c1, be a slightly different constant. Okay, but it's still a constant. Next up. All right, so very similar, just we don't have an x over here, so what's going to happen this time? Well, to get a monomial denominator, let u equal 6 minus x. Du will be 0, so just negative dx. And remember, it's the dx we're going to be getting rid of. So let's go negative du is equal to dx. And we didn't need to solve this for x. There's no x over here. Okay, so ready? So 8 is 8. Well, you know what? 8's just a constant. So let's bring the 8 out in front. 8 integral. Okay, so the 8's out front. We've got a 1 over 6 minus x. So that's 1 over u. And dx is negative du. Well, negative is just a constant. So let's go negative 8 integral 1 over u du. And that will be negative 8 ln absolute value of u plus c. But again, it's not about u. It's about 6 minus x. So negative 8 ln absolute value 6 minus x plus c. And that's that one. Okay, 2x over x plus 1 quantity squared. So what are we going to do? Well, same deal, right? So we are going to let u equal x plus 1. Now, we do need x, right? So we're going to solve for x. So x will be u minus 1. And we need du. And that's going to be 1 dx. So just plain old dx. Right, and that derivative is 0. Okay, so we are ready to substitute. So we have 2 times x, but x is u minus 1. So 2 times u minus 1 over u squared du. So 2, kick it out front. And we have now u minus 1 over u squared du. Alright, so that's 2 times. So let's separate this out. So we'll do u over u squared. So the integral of u over u squared du minus the integral of 1 over u squared. 1 over u squared du. Okay, so simplifying away. So u over u squared is 1 over u du minus integral. Let's rewrite this. Let's call this u to the negative 2 du. And come down a bit more. All right, so we have 2. So this integral is ln u, right? Well, or the ln of the absolute value of u. And this is going to be, so what, u to the negative 1? And put a negative in front then, so this will be plus u to the negative 1. And then let's throw in a constant c. So 2 times ln, it's not about u, right, of x plus 1, absolute value, there we go, plus, well, that's 1 over u, but u again is x plus 1 over x plus 1 plus c. And there we go. That's that one. Okay, moving right along. Warm up number 2. Alright, so how do we do this? Well, I mean, the easy way is just going to be to say, well, I've got root x, which is x to the 1/2 x squared plus 3 dx and multiply this through. So the 2 here is 4 halves, right? So we add, so this is 4 halves. So this will be plus 1 half, right? So it'll be x to the 5 halves plus 3x to the 1 half dx. And then really all we need to do is take each of these guys. Right, so what do? We add 1 to that. So that's going to become 7 halves. X to the 7 halves. Now we multiply that, right? So when we do the derivative, we'll get 7 halves times this to the 5 halves. So then we're going to need a 2/7, right? 7 halves times 2/7 is 1, x to the 5 halves. And then this guy here, well, this is going to be a 3 halves, right? And we take the 3 halves and multiply it by that. So 3 halves times something wants to become 3. So that's going to be a 2. Okay, so 3 halves times 2 will give you 3x to the 1 half. So 2x to the 3 halves plus c. Okay, so straightforward enough. So monomial to the root side, we can expand the integrand so it's no longer a product. The integral is then easy to determine. That's the goal here. So let u equal x minus 1, so that underneath here we'll just have a root u. But we've got an x out here, right? So x is going to be equal to u plus 1, and du is just equal to dx. Du, that's going up here, right? Du is 1 dx, or just dx. So this becomes the integral of, so x is u plus 1. Root of x minus 1 is root u, and then du. All right, so getting off the edge of the screen. That's u to the 1 half, right? So this will be u to the 3 halves plus u to the 1 half du. So that's going to become 5 halves, so 2/5 u to the 5 halves. And that's going to become 3 halves, so plus 2/3 u to the 3 halves plus c. And you guessed it, it's not about u. So x minus 1 to the 5 halves plus 2/3 and x minus 1 to the 3 halves plus c. All right. So just a way to simplify. It's definitely time for a definite integral. This one's a little challenging, but all right, let's see what we can do with it. Well, let's say we want to get rid of this. So we're going to start off over here. Hang on, I gotta get placed on the tablet. Let u equal 2 plus 2 root x. Okay, so then du is going to be, so what is that? 0, that's a half. A half times 2 is 1, and that becomes x to the negative half. So x to the negative half dx, right? So that's 1 over root u. So du, or sorry, 1 over root x dx, right? And because it's the dx, we're going to be replacing. So we're going to multiply both sides by root u. Sorry, root x. So root x du is equal to dx, right? So that's this guy taken care of. Now, what else do we got going on here? Well, we know that u is equal to 2 plus 2 root x. I can't fix that. U is equal to 2 plus 2 root x. U minus 2 is equal to 2 root x. And root x is equal to u minus 2 over 2. And so we will be getting rid of the root x here and writing it in terms of u instead. So from here, we pop in, not good with the arrows here. So root x, so u minus 2 over 2 du is equal to dx. All right, but wait, there's more. We're doing a definite integral, right? So we need to take x from 4 to 9. Okay, so hang on, let me split out this a bit more. Let's give ourselves a little space in here, a little more work to do. When x is equal to 4, well, then u is equal to 2 plus 2 root 4, which is 2 plus 2 times 2, so 2 times 4. So u is equal to 6. So when x is 4, u is 6. And when x is 9, wherever did they get these numbers? When x is 9, u is equal to 2 plus 2 root 9, right? Which is 2. So that's 3 times 2 is 6, which is 8. So u is equal to 8. And we do this because we're doing a definite integral. And so I don't need to do what we did with the indefinite integral, x, to u and then back. We can just evaluate. So this will be equal to the definite integral from u is 6 to u is 8 of. Okay, so this is u. So this whole thing is 1 over u. 1 over u. And dx is u minus 2, bracket, u minus 2 over 2 du. All right, let's simplify away. So, okay, you know what? Let's get rid of the 2, but it's not a 2, it's a half, right? So let's go out here, equals 1/2 integral, definitely from 6 to 8. Right, that's gone. So we have 1 times u minus 2 over u, or just u minus 2 over u du. And do we know how to handle this? We do. If we can get our scrolly back. There we go. Scroll down a bit. Okay, so we have 1/2, 6 to 8. So u over u is 1 minus 2 over u. So we're just splitting this up. U over u is 1 minus 2 over u du. So we got 1/2. And we have, so that integral, that's going to be u minus 2 ln absolute value of u evaluated from, we got the 6, we got the 8. So, start plugging in. 1/2. All right, so let's do it this way. So we'll say u evaluated minus 2 ln absolute value u, also square that circle. All right, scroll down. Might have to extend the page. I'm going to extend the page. Extend the page, scroll down. Now you can always play back and forth if you need to see what's up there. So, okay, what do we got? 1/2. Okay, what's this guy? So this is going to be 8 minus 6. Minus, okay, so this is going to be 2 ln 8. 2 ln, now it's the absolute value of 8, but that's just 8. So 2 ln 8 minus 2 ln, and again, absolute value of 6, but that's just 6. A little off kilter. So this is 1/2. All right, so we've got 2 minus, let's take out a 2 here. So minus 2, and we'll get ln 8 minus ln 6. So 1/2, 2 minus 2. So, this could become ln of 8 over 6. And multiplying through, can I squeeze? We'll go down just a smidge more. Okay. And multiplying through by 1/2, we get 1 minus, and that'll also be a 1, the ln of, and 8 over 6 is 4/3. So, evaluated, we get 1 minus the ln of 4/3. I think that's it for part B. That is it for part B.